This is Euclid Book 10, proposition number 71, and it says as follows. If a rational and a medial area be added together, four irrational straight lines arise, namely a binomial or a first bimedial or a major or a side of a rational plus a medial area. Okay. First, we're going to let AB be rational. That's this area right here. And we're going to let CD be medial. That's this area right here. Okay? I say that the side of the area AD, which probably be this length right here, is a binomial or a first bimedial or a major or a side of a rational plus a medial area. For AB is either greater or less than CD. Okay? Let AB be greater than CD. So this is going to actually end up being bigger than this. Let a rational straight line EF be set out. Okay? This is a rational straight line right across here. Let there be applied to EF the rectangle EG equal to AB. Okay, so the area inside of here, which is EFGH, this area right here, is going to be equal to this area right here. This is the same size as this. And we're going to produce EH as the breadth. This is EH. And let HI, this area right here, equal to DC. This area and this area are now going to be equal in size. Be applied to EF. We did. Producing HK as its breadth. This is going to be the breadth of HI. Okay. Then, since AB is rational and equal to EG, therefore EG is also rational. Since this is rational, so is that. And it has been applied to EF. Okay, well, EG was applied to EF. And it produced the EH as the breadth. Therefore, EH is rational and commensurable in length with EF. Okay. EH is rational and it's commensurable with this. That's by Euclid Book 10, proposition number 20. Again, since CD is medial, okay, so this is a medial area here, and it's equal to HI, which is this area right here, then this area is medial. And has been applied to the rational straight line EF, producing HK as its breadth. This is the breadth of this area. Therefore, HK is rational and incommensurable in length with EF. This line is a rational line, but it is incommensurable with this length right here. That's by Euclid Book 10, proposition number 22. And since CD is medial, since this is medial, while AB is rational. Okay, so this is medial, this is rational. Therefore, AB is incommensurable with CD. This area and this area, they're not commensurable. So that EG is also incommensurable with HI. This area and this area are not commensurable. But as EG is to HI, as this is to this, so is EH to HK. EH to HK. And that's by Euclid Book 6, proposition number 1. Therefore, EH is also incommensurable with length with HK. This and these two lines right here, this one here and this one here, they're incommensurable. This is by Euclid Book 10, proposition number 2. And both are rational. Okay? This line is rational, so is this. Therefore, EH and HK, this one and this one, are rational straight lines commensurable in square only. Therefore, EK is a binomial. This whole length here is a binomial. And it's been divided at H, which is by Euclid Book 10, proposition number 36. And since AB is greater than CD, since this is bigger than this, while AB is equal to EG, while this is equal to this, and CD is equal to HI, this is equal to this. Therefore, EG is also greater than HI. This is greater than this. Therefore, the line EH is bigger than the line HK. The square then on EH, this is the square on EH. Okay, now what you're going to do is you're going to take the length of EH, you're going to draw a square out of it. And all four sides of the square are going to be the length of EH. Okay, the square then on EH, which is this, is greater than the square on HK. Now where did the square on HK come from? We took this line, we formed it into a square, and all four sides of the square are the length of HK. So let me read this again. The square then on EH is greater than the square on HK, either by the square on a straight line commensurable length with EH, or by the square on a straight line incommensurable with it. First, let the square on it be greater than by the square on a straight line commensurable with itself. Now the greater straight line HE, which is this one right here, is commensurable in length with the rational straight line EF set out. So these two lines are commensurable. Therefore, EK is a first binomial. This line is the first binomial. This is by Euclid Book 10, second set of definitions, number 1. But EF is rational. This is a rational line. And if an area be contained by a rational straight line and a first binomial, the side of the square equal to the area is binomial, which is by Euclid Book 10, proposition number 54. Therefore, the side of EI is binomial. Okay? Well, EI is all of this plus this together. Okay? So the side of EI, which is this right here, is the binomial. So the side of AD is also binomial. Okay, so AD is this area plus this area combined. So this right here is a binomial. Next, let the square on EH be greater than the square on HK, so this is going to be greater than this, by the square on a straight line incommensurable with EH. Now the greater straight line EH is commensurable in length with the rational straight line EF set out. So this is commensurable with this. Therefore, EK is a fourth binomial. This is a fourth binomial now. Okay? We're changing things just a little bit. This is by Euclid Book 10, definition number 2. Well, second set of definitions, number 4. But EF is rational. This is rational. And if an area be contained by a rational straight line and the fourth binomial, the side of the area is the irrational straight line called major. This is by Euclid Book 10, proposition number 57. Therefore, the side of the area EI is a major. Now we're going to say that this line is a major. Okay? We said it was something else a while ago. Now this line is a major. So the side on the area AB is also a major. Okay? So now we're going to say that this line here is a major. Now let AB be less than CD. Now we're going to say that this area is less than this area. Okay? Therefore, EG is also less than HI. This is less than this now. So that EH is also less than HK. Now we're going to say that this line is not as long as this line. Now the square on HK, that's one, this right here, is greater than the square on EH, this one here, either by the square on a straight line commensurable with HK or by the square on a straight line incommensurable with it. First, let the square on it be greater than the square on a straight line commensurable in length with itself. Now the lesser straight line EH is commensurable in length with the rational straight line EF set out. So this is commensurable with this. Therefore, EK is a second binomial. This is now a second binomial. but EF is rational. And if an area contained by a rational straight line and a second binomial, the side of the square equal to it is a first bimedial. It's by Euclid Book 10, proposition number 55. Therefore, the side of the area EI is the first bimedial. So this is a first bimedial. E to K, that's the first bimedial. So if the side of AD is also a first bimedial, this is now first bimedial. Next, let the square on HK, which is this one right here, be greater than the square on HE, which is this one right here, by the square on a straight line incommensurable with HK. Now the lesser straight line EH, now we're going to say this is less than this. This line here is commensurable with EF. These two lines are commensurable. Therefore, EK is a fifth binomial. So now we're going to say that this line across here is a fifth binomial. But EF is rational. And if an area be contained by a rational straight line in the fifth binomial, the side of the square equal to the area is a side of a rational plus a medial area. This is by Euclid Book 10, proposition number 58. Therefore, the side of the area EI is the side of a rational plus a medial area. Now we're going to say that this is the side of a rational plus a medial area. So if the side of AD, which is this right across here, is also a side of a rational plus a medial area. And that concludes the proof. I will tell you more in a future video. Stay tuned.